using this rule that if our p-value is small, or in this case specifically less than or equal to our significance level, we reject that null hypothesis. And what we want to do is just given p-values, making our conclusion for our hypothesis test. So let's go through these examples here, where we have a company's concerned. This is the same example as before with the emission standards. So just as a reminder, our null is that the proportion is 0.8. Alternative was to prove that it's less than 0.8. And the idea is they have the sample data, they would have found their z-score, and eventually they would get to the point that they have here, which is that they have the p-value is 0.0009. And what we need to do is evaluate, is this number small or large? And it certainly looks small, but to determine for sure that this would be considered a small number is to compare to our significance level. Now notice with all of these actually, they don't state a significance level to test against. So since they don't specifically state the significance level, we automatically use a significance level of 0.05. So what we want to do is compare the p-value to that value of 0.05. So what I often do is you have your p-value, and right next to it, write out your significance level. And what you want to do is figure out which symbol goes in between. Is it going to be the less than symbol or the more than symbol? And for us, this 0.0009 is less than that 0.05, which means our p-value is small. And when our p-value is small, this is where we reject the null hypothesis. This is where we have significant results that we can say, reject that, and we can conclude the alternative is true. So let's write our conclusion. So with our conclusion, we always want to state the p-value. So with a p-value of 0.0009, and what we have as a result is we have evidence that this is true. So there's evidence that, and then what we want to do is put together our wording for this alternative, which you can often find some idea of it in the wording. Like we wanted to test if less than 80% of their fleet meets emission standards. This is what we proved. We have evidence that less than 80% of the fleet meets emission standards. And when we have a small p-value, what this is saying is there's a 0.09% chance of seeing this sample result if this is true. So since it's so unlikely to see these sample results if this is true, it's more likely that this is true. We have evidence that this is the accurate statement. In part B, looking at that official poverty rate, remember the null was that the poverty rate is 0.148, and alternatively, we wanted to prove that the proportion is different from 0.148. So they run their hypothesis test, and we get a p-value of 0.273. So comparing this to our significance level of 0.05, we want to figure out what symbol goes in between. And for this case, that's going to be the more than symbol. So what this tells us is the p-value is not small. If the p-value is not small, this is where we fail to reject the null hypothesis. So like in this example, I was able to cross that out and circle our alternative. I can't do that here. And also, with these hypothesis tests, we never claim the null hypothesis is true. because we failed to reject it doesn't mean that I cross this out and say this is true. We don't know if their poverty rate is exactly equal to 0.148. All we know is that it's not significantly different from 0.148. So this is where the wording can get kind of funny in that we go through the same step of stating the p-value. So with a p-value of 0.273, and what we essentially state is we don't have enough evidence to state the alternative hypothesis. So those are our two conclusions. We either have evidence for the alternative or we don't have evidence for the alternative. But never do we make a conclusion that includes the null hypothesis. So with a p-value of 0.273, there is, and we could describe it as insufficient evidence their county has a different poverty rate than the rest of the United States. So the main difference is where we have our wording for the alternative, where we get to reject the null, we have evidence. Where we failed to reject the null, we have insufficient evidence. We can't claim it. With this last example, they have drugs that prevent seizures sometimes, have unwanted side effects such as depression, and they want to study a drug and look for such side effects. So they want to prove that there are side effects. So that's going to be our alternative. We're looking for evidence that there are side effects, and the null assumption is going to be that there are no side effects. So with this, they get a p-value of 0.06 out. And we want to compare this to our significance level of 0.05 and figure out, is this small or large? And that's going to be bigger. So because our p-value is large, we failed to reject the null hypothesis. Which means we can't get rid of this. We can't claim that there are side effects, so we just don't have enough evidence to say that there are side effects. So with a p-value of 0.06, there is insufficient evidence that there are side effects. Notice with this one, if we had used a different significance level, let's say they had run this with the significance level of 0.1. If we used a significance level of 0.1 and we're comparing 0.06 to 0.1, then we would have had the less than symbol. And with that less than symbol, now we reject the null hypothesis, and we would have evidence of side effects. So this is where the significance level, it can be adjusted, or it kind of depends on what they're trying to prove and how important it is, because with the different significance levels, it changes this rejection region. So with an area of 0.01, it becomes more difficult to reject, but with that, it requires very significant results. So that's where they might use, in medicine, where it's very important to have significant results in order to make some claims, they would create a smaller rejection region. Whereas 0.1 is kind of when it's not that serious of an effect. So this is kind of a medical scenario, so it's probably not good to use 0.1. In fact, they might even want to change it to 0.01, since it's very needs significant results to state these side effects. But this is what happens if you do work with other significance levels. It can change whether or not you reject that null hypothesis.